Hi, everyone. I'm Antonio. Thanks for taking some time to attend my talk. I'd like to present today what we think could be the next generation of the recently launched people chain, which we should call Identity Hub. I'm sure by now you have come across the term digital identity a few times, and I'm also as sure that basically each of us has a different understanding or definition for it. According to the all-knowing Wikipedia, a digital identity is data stored in computer systems related to an individual, organization, application, or device. For individuals, it involves the collection of personal data that is essential for facilitating automated access to digital services, confirming one's identity on the internet, and allowing digital systems to manage interactions between different parties. Within Polkadot, the identity space has been, since I remember, really fragmented, which I would argue is actually the main selling point of Polkadot as a technology. We have projects such as Kilt, the project I've worked for, and Doc, that rely on decentralized identifiers and verifiable credentials. We have Encounter, which provides safeguards against Sybil attacks by providing proof of personhood. Or yet the new people chain, which contains the identity palette and is considered to be the new source of truth for such identity information. Nevertheless, if we zoom out, we can see that each blockchain ecosystem actually does the same thing. So they have each their own set of identity solutions, and they kind of struggle to interoperate with each other as they each leverage the strength of the infrastructure they are based on. Let's zoom even further, and we can see that the identity space inside the crypto world is very much disconnected from the non-crypto world in the likes of Facebook, the European Union, the DHS, the Department of Homeland Security, or more generic solution providers such as Auth0. So the problem seems to be that the crypto projects tend to focus on crypto first and crypto-only use cases, seemingly forgetting that we could help the traditional Web 2 world. On the other hand, we can see that traditional identity solutions have been really reluctant to get involved with crypto for a number of reasons. One of them being the lack of primitives to solve the problems that live entirely outside of the crypto space, and that go beyond identifying blockchain accounts, get them attested to be a person, or give them user-friendly names. For instance, think about supply chain use cases, or even just the types of the entities involved go beyond people and definitely beyond blockchain accounts and involve ports, ships, containers, goods, cross-border transactions, workers that work in different countries and different jurisdictions, and more. And by definition, such a use case cannot rely on a single solution that solves all of the problems. But different parts would have to, the different parts of this system each have their own different set of requirements in terms of privacy, in terms of security, in terms of accountability, and yet they all have to be interoperate with each other so that we can achieve the goal of shipping one pair of socks from India to Canada. So after talking about the problem, let's try to look at possible solutions. To the problem of fragmentation within the Polkadot space, the people chain seems to actually be one step in the right direction. Nevertheless, the fact that it's called people chain bakes in a very strong assumption that it would only deal with people, or that at least people would be the only first-class citizens of such a system. And this assumption, plus the fact that it is tailored to chain-first use cases, makes it a good fit, but only marginally, because more involved use cases would not be able to fully benefit from it. With the transition to GEM and the concept of a distributed and decentralized supercomputer, deploying the current people chain as a GEM service could potentially solve the problem of the fragmentation within the wider crypto ecosystem. But even if other projects would have a service, so would use such a service on GEM, the underlying issue of providing a uniform semantic layer for such identity information to be shared between all the different projects would actually still be a problem that we need to tackle. So yeah, having a GEM service still somehow doesn't fill the gap that we should be most interested in and where we can capture the most value, which is try to serve a purpose for use cases that go beyond the crypto use cases. So let's now try to look at what is out there. What we want to look for is a way to integrate crypto and non-crypto use cases in a manner that is as seamless as possible, without requiring either side, so neither the crypto solutions nor the non-crypto use cases, to make big changes to the way they currently work. And of course, we want to capture that within Polkadot, before, but especially also after Gem is live. In the Web2 world, linked data represents a great tool to ensure that the total value deriving from aggregating data from different sources is greater than the sum of the value that each of the single solutions provides. And this should also apply to Polkadot as well, since Polkadot has made secure heterogeneity one of its core value propositions. And that will not change with Gem. So what we currently have instead is different chains competing with each other in some areas, including identities, which means that the more places a user's identity is spread onto, the harder it becomes to manage. And as a result, I would argue that the final value that you get is actually less than the sum of each individual value that each solution provides. But we want the opposite. So with linked data being the semantic framework to aggregate such data from different sources, RDF, which stands for Resource Description Framework, provides the practical tools to serialize and deserialize such identity in a way that is standardized and understandable by all the parties involved. It is a Web3C standard, which means that it has gone through multiple refinements involving people from all over the world in many different industries contributed to it. So yeah, we think that a combination of linked data and RDF represents a very promising way forward to try to bring down the barrier of cross-chain and also cross-ecosystem identity interoperability. Yeah, probably not many are familiar with the RDF, so I'll try to give a little bit of explanation, a few examples to show how it can be used before moving on and describing the actual Identity Hub vision that we have. Yeah, so let's take the sentence, Alice is 18 years old, which represents a claim about Alice's age. In RDF terms, this is an RDF triple because it's made of 3 components, a subject, a predicate, and an object. We can also refer to it, such a triple as an identity claim. So in this case, Alice is an example subject. In reality, the subject of a claim would have to be an IRI or a URI, so something that has, let's say, a namespace and an identifier. So a URI could be, for instance, Alice's account, prefixed with some namespace, or her decentralized identifier, her DID. Then all the other claims that are related to Alice's subject would all have the same URI as the subject. The age is the predicate of the claim. The set of valid predicates that can be expressed about a subject is usually defined, it is defined in a so-called vocabulary, which provides a one-to-one function between a predicate, so age, and its unambiguous meaning. For instance, the vocabulary could contain a predicate age and define it to be a numerical value with a very specific semantics. 18 is then the object, which is the value associated with the predicate. An object can be a concrete data type, for instance, a number, a date, a string, or it can be also itself a URI, so that we can link the object of a claim with that can be the subject of other claims. And in this way, we form a graph structure of identity information, which unlocks the full potential that I'm talking about. And we will see an example later. Yeah, identity claims, as I mentioned, can also be nested and themselves be the subject of a different set of claims. So this means that one base claims, for instance, Alice is 18 years old, can be attested by multiple different entities. One entity's attestation can also itself be reacted by other entities, very similar to what you would see usually in Google reviews. You have a place which claims to be a nice restaurant, then there's people leaving reviews for such a place, good or bad, whatever it is, and then you have people giving a thumbs up or a thumbs down whether they found the review useful or they agree with the review. And in the case of Google reviews, the process stops there, but in the case of RDF, there is not really an upper limit on how much we can go with recursion. Of course, we don't see more than 3 to 4 levels of recursion, but if there are, the technology doesn't get in the way. So yeah, the claim, the identity claim is Bob asserting another identity claim. The subject of this new claim is actually Alice is 18 years old. The predicate is, for example, attested by, and in this case, it would represent exactly the act of attesting something with a very specific semantic, which would have to be described in an unambiguous way in a vocabulary. And then we have the object, which is the value of the predicate, which in this case is Bob, or it would rather be Bob's URI, for instance, Bob's DID or Bob's account. And the cool thing here is that Bob itself might have a set of identity claims about themselves, which would be available in such a graph data structure. For instance, then you could retrieve information about Bob to make a judgment whether his attestation of Alice's claim is actually to be trusted or not. Yeah, let's see some example of regular sentences. How can they be transformed into identity claims? Yeah, example number 1. Account 13G, blah, 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 real name is Antonio Antonino. If we assert that there is only a single way of representing a given name, which would be the given name predicate, then all entities that want to ever express the name of some other entities would have to use the same predicate. And this avoids a problem that we've observed in the space, that there is a proliferation of similar but not quite the same predicates. And in this way, we only have a single way of representing information, which facilitates the interpretations of those claims as well. So in this case, the account 13, the Polkadot account 13, blah, 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 is the subject of the claim. And then the predicate would be the given name, and Antonio Antonino will be the object. If someone else wants to attest something, wants to attest the given name of a different account with a different value, they would be forced to use the same given name property. And now we can see that all of the claims attesting the same thing would always have the same predicate type, avoiding proliferation, as I mentioned before. Yeah, there would also be a single way of representing alternative names. For instance, we can think about the alternate name, which is actually a predicate that is defined in the schema.org, which is a repository of, let's say, predicate that we can already draw from to represent real-world relationships. And you might start to see how powerful this is, especially if you are a dApp and you want to show usernames for users. Right now, you'd have to fetch information from a specific chain using chain-specific logic. So each chain might represent user-friendly names in a different way, and that's actually the case today. And then you can go to the people chain, and you can also fetch the entity details from there for the same account. And then in case of conflicts, it's not clear what to do. At least it's not specified anywhere. And these frameworks makes them all of them equal. So it's trivial to fetch all the alternate name for a subject because you already know what you are looking for, and it's the alternate name predicate. And this will all be in a single place, which would be Identity Hub. Yeah, another example is for proof of personhood claims. Here, yeah, we can see that the claim number 1, so account 13 blah, 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 is a person. I could also claim to be a person. Nevertheless, the other party would not trust me to make such a claim, but they might trust entity X to attest that about me. So entity X can be an organization, for instance, Deloitte, issuing KYC attestations. It can be an autonomous system, for instance, in Cointer, or also some ZK credential providers. The framework is flexible because it allows claim 1 to be issued by anyone, even a cat, pretending to be a person. But of course, the interesting bit is claim 2, which certifies that the account is indeed a person. And this should, yeah, hopefully never be possible for cats. But also for privacy-minded people, do not despair, because the RDF framework does not force the information to be public all the time. Rather, it informs information to be always clearly defined in terms of semantics and structure. So this means that it would also be perfectly fine to define a predicate, for instance, ZK birthday info in the global vocabulary, expect it to be some hex-encoded string of some ZK witness, and let entities issue claims of this kind. And this is possible because the framework is rather flexible and delegates making judgments about claims to the two parties interacting with each other. We have on one side the entity about which claims are being made, in this case, entity Y. And then we have on the other side the entity consuming those claims. We could call it verifiers. So this means that the same claim, for instance, the ZK birthday claim, might be considered acceptable by some entities that trust entity X to make such attestations, but other entities might not trust it, even though the ZK proof checks out. They don't trust entity X to make such type of assertions about subjects. So yeah, what is the Identity Hub? After this kind of not so short explanation of RDF, it is a generic data store of structured RDF identity claims that come from all the connected subsystems to Identity Hub. A subsystem could be a parachain, a smart contract on the parachain or on a relay chain, the relay chain itself, or even locations that are remote and bridged with a bridge. It aims to be the unique source of truth for connected subsystems and dApps. It provides a standard interface for reading and writing identity information, and it aims to act as the liaison between the crypto and the non-crypto world. But as important is to highlight what it is not. And it is not a replacement for any of the existing identity solutions. It is not, does not aim to be a proprietary solution developed and governed by a single entity. And it doesn't aim to be the provider of absolute truth, but rather it's a place where information is collected in a standardized way, making it easier to aggregate and derive contextual information, which might not be directly obtainable by isolated claims that you see on individual parachains, for instance. Let's see how it would actually interact with the different use cases, starting from the creation of a new identity, which could be, for instance, registering a name, a user-friendly name on some blockchain. I wrote chain here and not parachain because, it could be the relay chain itself. If it needs to attest some claims about some events, for instance, that could take place, the relay chain could be actually one of attesters of some claims. A trivial example is the user setting up a new identity on one chain. Then the chain, this is chain-specific logic, converts this new identity information into triples that are then sent to Asset Hub. Converting from chain-specific information to triples and back should be really straightforward because Rust makes it extremely easy. It's nevertheless up to each chain to implement the logic that decides what will be stored on Identity Hub, and what doesn't get stored there. For instance, there might be some information which might not be suitable to be aggregated with other information from other parachains, so it can stay local to that chain. And for instance, a user decides that they don't want their identity to be exported to Identity Hub, then it would stay local to chain A. And the reason why I mentioned Asset Hub, because it's in some way it's similar to Asset Hub. Not all the assets are on Asset Hub, but only the ones that get the most value from being on Asset Hub and share between all the parachains. And we see identities being shared and aggregated in the same way. For the deletion, same as before. Something happens on chain A. For instance, the user deletes some information. Chain A translates this into the relevant set of triples, and then they send a delete command on Identity Hub to delete those triples. And of course, all the claims are namespaced by chain, so it's not possible for one parachain to delete claims that another parachain has previously stored. Not only Identity Hub would act as a normal data store of identity claims, but it could also act as the sole entry point for identity actions. So we could see a way where users start also their flow interacting only with Identity Hub, encoding some kind of identity action, and then Identity Hub would be responsible for forwarding those actions to the relevant chain, for instance, via XCM, and then the relevant chain would process this information, store it locally, convert that to triples and send them back to Identity Hub to be stored there. And this whole process wouldn't require a user to interact with more than a single chain, which would be Identity Hub. Sorry. And identity deletions would also work the same way. They would ask Identity Hub to delete some pieces of information. Identity Hub doesn't take any actions on its own, but it always forwards to the relevant chain. Because the relevant chain can then delete the state and send deletion commands back. In this way, we can enforce that the state between chain A and Identity Hub is always consistent, and Identity Hub doesn't delete anything without chain A knowing that. Besides user-facing interactions, Identity Hub would also make the lives of developer easier. For dApps and other off-chain applications, for instance, Identity Hub would represent the only place from which to fetch such identity information, although I'm using the Identity Hub here. The DApp would most likely connect to an indexer, which aggregates data from events that Identity Hub itself generates. And because RDF data, what I talked before, is highly structured and semantically unambiguous, applications can actually execute very complex queries using battle-tested technologies for querying big data, for instance, the SparkQL language. So one example of a query could be, get me all of the entities that have been certified by entity X to be humans, for instance, or get all the entities that have a kill ID and have received a KYC credential from Deloitte, get all the user-friendly names grouped by entity that have been certified by Register X with a confidence of at least 4 out of 5, get all the parachains from which entity X is a collateral as attested by the parachain itself, get all the entities that are part of the Polkadot Fellowship and have a Deloitte KYC credential. So that one is kind of a use case for off-chain applications to query data using querying languages designed to work on big data. Of course, because the information is stored on-chain, it's also available for on-chain use cases, using technologies such as XCM, which already exist, XDQ, which is in the phase of being, last time I checked, being still discussed, or the decentralized identity provider, which is an alternative way of sharing data across blockchains without using XCM. What are the implications of Identity Hub? Well, it would provide, again, an unambiguous, well-defined semantics of identity claims, which I haven't seen so far happening in the ecosystem, structured, standardized, and battle-tested serialization and deserialization of those claims. It provides a unified interface from reading and writing identity-related information. It would provide native support for crypto and non-crypto use cases, and also for on-chain and off-chain use cases. And if these were ever to become first a system parachain, but then also a gem service, the information would be even easier to access and modify synchronously because of the new model that gem introduces. Yes, and it's, of course, the design will have in mind that it will have to be gem ready for when the gem actually happens. So what happens now, we try to pitch this already in the Parachain Summit in Thailand, and also we opened a Polkadot forum a while ago. Unfortunately, we didn't get a lot of answers. We only got, I think, a couple of comments. They were positive, though, so that's what's keeping us from trying to advocate more for what we envision the people chain could look like. I think we might want to go for a wish for chain proposal to see if the majority of dot holders actually see value the same way we see value for such a solution. If that goes through, then there will be a whole of RFC process. We envision more than one RFC for the different use cases that I've shown you. Basically, a data store, or using it as a proxy for other chains, or using it for off-chain applications, or using it for on-chain application. Those are all potentially different RFC proposals. And then, of course, we would also be willing to implement it if the whole actual process goes through. And yeah, eventually also deploy it. Yeah, thank you for your time. I think I have a couple of minutes left for questions. Feel free. And yeah, some legal notes. Yes.
Hello.
Hi.
Tommy from Finland. Used to be an ambassador, not anymore. So I have 3 questions. I'll give you 2 first. They're related. Is this data on Identity Hub encrypted, or is it visible to anyone about the identity claims? And where is the user able to control that if they allow it to go to the Identity Hub or not? Is it up to the different smart contracts, different parachains to control that, or is there like a centralized place in our decentraland to control that?
No.
3rd question later.
Yeah, okay. Yeah, thanks for the question. Those are really interesting ones to answer. The first answer to the question whether it's encrypted is that it could be. It just, like Identity Hub provides a framework for structuring data. The content of those data, so what's inside those envelopes, Identity Hub doesn't care. There could be encrypted data if we have proper predicates that refer to the data being encrypted, then it could be encrypted. It could be not encrypted. It could be personal information. It could be not personal information. Like Identity Hub and the RFT solution is just providing the container and the semantics for the data, but what's inside Identity Hub doesn't make any judgments. As for the second questions, I can probably go back to that slide. Yeah. So in this case, or also in this case, but this case is just basically one more step. Identity Hub would forward the payload as it is to chain A, but oops, okay. Yeah, what matters here is that the contract between the user and chain A, which is what matters. So, for instance, in the extrinsic that set up a new identity bit, there could be a flag saying, I want this information to be available on Identity Hub or not, and then it would be the chain A that has to enforce that contract between the user and themselves. Identity Hub is only the receiver of that, and it doesn't make any judgment about the contract that the user has with that specific chain. So it's always regulated between those two entities. Yes, yes. Yeah. Oh, okay. Thank you. I guess. Okay. Thank you.
Yeah, amazing. Thank you very much. Amazing. Loved that.